Well, hi, good morning. Thanks for joining me in my shop here for another day of hopefully something interesting happening. It's April 26th today. So, I've done all this alignment work, first time through alignment work, and I still have some older capacitors in this radio. You can see one here, one up here, one in there. By older, I mean wax capacitors. There's 3 of them, there's one right here. That's not a lot, that's only 4. Ooh, 5, 6. There's 2 big ones up here. There's a lot of big capacitors in this radio. 1, 2, 3, 4 big capacitors. Well, anyway, what I'm thinking is I will set the radio up with a known signal. Take a signal from my signal generator there. Get everything stable. Pick a band, maybe pick a band, pick a frequency, set everything up, read the maximum volume coming out of the speaker, shut off the radio, change all those capacitors, turn the radio back on, see what the difference is. That's a lot of capacitors. Maybe I'll turn it on a few times during the process here, since there are actually more capacitors than I realized. That's my thinking. Could also measure the AVC voltage, which might actually be a better approach than the audio, so I'm going to set up for that too. We haven't measured the AVC in this radio yet, so let's do that here. Now, where to get the AVC from? There's the schematic right here. So a typical spot is to pick it off the volume control, top of the volume control. On this radio it goes into this tone control switch, which I'm not going to try to fathom. So we come up here where the audio is coming out here. Some diodes. The audio is developed right in here. The AVC is delivered out this way through this resistor. This is probably a whopper resistor here, probably 1,000,000 ohms or more. So I want to get on the low impedance side. How are you going to find that? Wow, right off the terminal of the transformer. So it's just tricky to find this spot in the radio. I look more closely at the switch here. Funny switch what it's doing. So here's the audio coming out, coming down, coming around, coming in, and heading out. It's got to head out in every case except for when it's switched to phono. Oh my gosh. Top of the volume control. Gotta go there. Volume control. Top and bottom. Now, let's just look at the bottom of the volume control. How is that dealt with? Straight to B minus. That should be visible. I see a black wire. The other side is going up into the tone switch. The other side is going into the tone switch. I've got it. Okay. Quickly. And we'll see how this affects the radio. It shouldn't. Nothing. How about affecting the meter? Well, we haven't got anything tuned in just yet. Expecting a negative voltage. There it is. We're on the 5-volt scale. Signal should push that up 10, 15 volts, something like that. Now, what band are we on here? Let's figure it out. Okay, so let's broadcast, shortwave. Why don't we pick one? We'll go one further. Band spread. Band. And that is, I don't trust my memory, 11 megahertz. We should get something should come out of the radio as I get down around 11. Okay, something not right here. Broadcast. Yeah, that's definitely, I'm just touching the broadcast antenna. Broadcast. Shortwave 1. Don't tell me I messed this up. Let me look again. Not going to be anything other than 11 megahertz. Uh-oh. It's definitely 11. I'm up, let's go in the middle. And I have it hooked up. Oh, that's the problem. I have it hooked up to an outdoor antenna. Not to the signal generator. Okay. Problem solved. There. That's fairly low. Now we'll find it. We're -3 on this meter. On the ABC meter. Oops, I'm standing on the camera wire. We're getting about 4 volts here. Tune it and watch this. A little more. Something funny about this tuning knob here. I won't go into it, but it's not an easy thing to get it to the max point. Okay, I don't need that. The beauty of this is I can fool with the volume and it doesn't affect this at all. Whereas, of course, the other meter is volume setting sensitive. So I think we're going to stick with the ABC meter. Now, how sensitive is this to little things being done? Shouldn't be sensitive at all. Stick my finger right in there. Something will be sensitive. Okay, so that's nice and stable. Full voltage to the radio. So I think that's a valid reading right there. Now, these capacitors I'm going to be changing out. I don't really expect them to boost the ABC, but it might. What I'm thinking is other more subtle problems are going to go away. And maybe we can't even hear those problems, like heterodyne due to oscillations, or signals getting back through the radio because the capacitor is not snuffing them, getting from the powerful end of the radio to the sensitive front end, then coming through again, causing various effects when you're tuning, mostly heterodyne tones. There was a squawk. There was I can't, I should have made notes. One of these bands at the extreme end would squawk a bit or go into oscillation. I found adjusting these two adjustments seemed to really knock that out. But probably one of these capacitors is supposed to knock that stuff out, or not allow it to happen. And it has. And there's another capacitor. Now I got a whole bunch in here. 1, 2, 3, 4, 5, 6, 7. 7 capacitors. One of these is on the will be on the screen circuit, and since they haven't made this easy, I'm going to try to figure out which one is on the screen circuit, and we'll go after that one in particular. So this is still showing up here. We'll make an accurate reading of it now. Just write it here. 5 volts. .3. Okay, good. We can shut off the radio. And yeah, I'm going to stop the camera for a minute while I sort out which of these is the which ones anyway are responsible for quieting, let's say quieting the B plus circuits, stopping them from being involved in feedback. Okay, so I think I've identified 2 of these. So this guy up here, this big one here, one end's going to the chassis ground, okay, which is the same as this B minus line here, and the other end is going into this tone control combo switch. So what I did was I looked at the listing of capacitors. It doesn't take long to spot where some 0.1s are. There's 2 0.1s there, 33 and 34. Come up here, 33 and 34. 34 goes to the chassis and into the tone switch. Chassis and into the tone switch. That's it there for sure. 33 goes from ground and it goes up to the screens of these 2 tubes here, and maybe more because I see a screen takeoff going over here. So this is the guy who's quieting all the screens. This is a very important capacitor, and it's this one. Well, I know it's this one because one end goes to B minus like that, and the other end I can see coming up to a terminal on a 6BA6. It's pin number 6 it's going to, and if we look at the pin out for 6BA6, pin number 6, right to the screen. So those 2 guys, they're not doing the same thing. It's the screen guy's doing one thing, and the other guy I'm not sure what he's doing here. Seems to be on the, I don't know what the other one's doing. So this great big capacitor turns out to be just a 0.01. Nothing. I thought it was, wait a minute, hold the fort. It's supposed to be a 0.1. It looks like a 0.1. Why do I think it's a 0.01? Because it says on it. What's it say on it? Okay, camera's kind of tangled up here. .1. Yeah, 0.1. They put the point way up in the air there. 0.1. Okay, that makes sense. That's what it should be. Okay, so I'm gonna. I think I'm just gonna replace. You know what? Like this. Yeah, right. I'll just replace this one, and we'll see what happens. Okay, let's give this guy a test here. See if he's leaking. Now this is a great another great looking capacitor. They don't look any better than this. Sealed right up beautifully. But the last one surprised me by being leaky when I didn't think it would be. Let's see what this one does. Now the last capacitor was critical. A small leak in that capacitor throw the radio off. This one, probably not so important. 50 volts on the eye. Well, that tells the story. Once again, you cannot judge the book by its cover. So this guy is bad. He's bad. They're bad. Bad, bad, bad. again, because of where it is in the circuit, a tiny leak of a few coulombs here and there won't really matter, I think. I would test it for its capacitance, but if it's leaky like that, the tests aren't accurate. In fact, they tend to overstate the capacitance. So, okay, so I'm going to put in the replacement here, and what will we do then? What will we do then, my little visitor? Yeah, that's right. She wants to go back outside. Because I'm going to put the camera out here. This might be a little much for the camera. Nice sunshine out there. Yeah, it's a little too much for the camera. Okay, yeah, it's tough being in the shop when the sun is shining like that. Isn't that right, Shadow? And no answer comes to her reply. Okay, I gotta go deal with the cat. I'll stick that capacitor in and we'll give the radio a go. Okay, that's one done. Let's give this radio a test again. So I haven't changed anything in terms of settings on the radio or the equipment. But there is a warm-up issue here. The radio is definitely cooled down, so it could potentially take quite a while to warm up. And the number we're going for on there, which I cleverly wrote down somewhere, 4.3. So 4.3 on here, way up here. That's where it is. Now a couple things may have happened here. I don't think it's a warm-up issue now. So one is the radio's tuning may be a little bit different. So in a moment I'm going to tune the radio and see if we can pick it up. The other one is this may have affected the alignment of the radio in some way. Not exactly sure how that would be, but could be. Or somehow that higher reading was actually a bad reading and this lower reading is a better one, but generally speaking, bigger is better. Okay, so it's not going anywhere on its own. I'll try tuning the radio now and just see if there's a better spot for it. Well, ever so slightly there was a slightly better spot. So it's a little counterintuitive that it would be lower. Now there's so many things wrong with the way I'm doing this that from a scientific point of view, this doesn't make it. But there we are anyway. Our new number, the new number is, this is going up. This is slowly going up. What would take that long? So a wild guess would be another capacitor is leaking and causing this to happen. You might say, well, that's good. That's a good leak. Look, it's going right up where it was. Or literally, did I just not let this thing warm up? Usually they're thinking 30 seconds is sufficient warm-up time. Not for alignment work. For alignment work, they suggest you let a radio like this run for half an hour or something. Well, it's above and still going. Well, it's just a totally unexpected behavior. Not that it's above now, but that it started out so low. Pin my meter now, so I'll have to change scales here. So the 5-volt mark was here, now it's just up above. It's still climbing a bit. I'm just going to let this run. So for my little break there, I just ran and watched a little bit of TV, and I've got that show on where the guys are mining up in the Yukon. And boy, I tell you, I think I have problems getting done what I'm doing here. Everything goes wrong for those guys who are trying to get the gold and the like. So, okay, I feel a little better. Now, where did we get to here? Whoops, moved the camera off the meter. So we're almost at 10 volts now. Well, that's a tremendous difference. Let me try tuning again. This is such a strange... I'm just gonna tune the radio and see what's going on. I'm just gonna sweep back and forth as smooth as I can with the knob and watch this meter. That's pretty good. It's probably the AVC that I'm fighting with, really. Yeah, that's as smooth as can be. So, like this kind of stuff. What's happening is I'm tuning it close to the proper signal. The AVC hasn't caught up yet. The AVC voltage grows way high. Looks to me like I'm on the money, but I'm not. A moment later, of course, the AVC voltage shows up and the meter goes up. Did that make any sense? That didn't even make sense, did it? I shouldn't try to explain anything here. I really shouldn't. Keep it all to myself. It's definitely AVC effect. So there we are. We're at 10.5 volts. New number. We got a new number out of that. Did that now? Is that really for sure? So my signal generator is an extremely stable machine. It holds frequency and it holds output just beautifully. You know what I did? I walked away with my pencil. Before I forget the number, 10.5. Okay, we'll add that to the sheet here. So we can assume better AVC voltage means stronger signal coming out of the IF. How would changing this capacitor improve the situation with the IF? Well, the screens of the IF amplifier tube and the one just ahead of it, the RF tube, affected by this capacitor. The capacitor is a little bit leaky. Could have been pulling down the voltage a little bit, but didn't I measure them all and they were all exactly right? So, you know, the long answer is I don't really know exactly why that would happen, but it did, and it's not too surprising. Now we're going to go to the next guy. Which guy? Which guy? There's 4 big ones in here. Big capacitors, big job. So one of them remains here. The other 2, I have to hunt down the other 2 here. So let's start with a list. There's the 2.1s there. Is there another 0.1? The answer is no. Okay, so I'm going to do a little hunting around to try to figure out what's going on with the capacitor that's tucked in up there. Okay, so it's very hard to see. There are actually 2 large capacitors up here. A really big one and a big one. I'm looking at the really big one. It says England on it. And it's hooked up to pin number 2 of the output tube, which I happen to have the book open at. Pin number 2 is a cathode. So that would sort of make you think that big capacitor is the cathode bypass capacitor, be this one. But this one's shown as electrolytic. There's no other capacitor in there. Is that capacitor's not electrolytic up there? And how big would it be? C47. C47. 25 electrolytic at 25 volts. Is that an electrolytic capacitor? Let's take a closer look. See what it is. The set's on, so I can only go so close. Oh, we're way out of focus here. Well, you know what? It could be an electrolytic one. I'm trying to look at the ends. The electrolytic capacitors have a particular look on the end. Yeah, that could be an electrolytic capacitor up there. July 1950. It's got a date on it. Well, it's a couple things now, and then in this radio it said 1950 or 51 or something like that. So I'm going to go, so what's that guy doing then? He's a bypass. Okay, so I'm going to leave that one just, well, yeah, I'm going to leave that one for now. I'm going to go after the one below it. It goes to a ground terminal, and the other lead, oh yeah. The other lead goes where? Oh boy. I gotta move that black wire there. It's a little awkward holding the camera here and doing this. So there's a bare wire here. That looks like a wire coming out of a transformer. This black one is going to a terminal up here. It's one of the speaker terminals. This must be the lead here. Can anybody follow it? It's that orange one. Yeah, the orange one. Got it? Well, I'm going to have to like nip this wire and then yank around on the capacitor and figure out which upper wire is it. So it looks like that orange one, and it looks like I need to refocus my camera here. Orange one. It's pretty tricky to know which is coming out of the end of that capacitor. I think it's the upper orange one, and it goes around to what terminal would that be? That would be 7, 6, 7, 6, 5. I think that's terminal 5. Let's just check that out. Oh, we can just keep the camera going here. Well, we can't tell anything here from. Well, there's a capacitor. That's a blocking capacitor. Didn't I change that out? Yeah. That's that metal one there. That's going to 7. The other one is going to 5. Okay. We must look in the book. 6 AQ5. This would be pin number 5 is a plate. 5 is the plate. 6 is the screen, interestingly enough. Oh, that could be going to 6. That could easily be going to 6. So screen and plate. What do we find on the screen and the plate circuits here? The output tube. Screen circuit. Comes up here. Oh my gosh, I mean, this wire goes everywhere. Yeah. Well, there's not a single capacitor hooked up to it. There's a resistor here. So if it's the plate, maybe it's that. What is that one? 50. That's number 50. Number 50. Ooh. 0.001. Well, that's no 0.001 capacitor. Well, we're lost. We don't know what it is. I probably didn't sight it properly. Let's go again on counting the... what I'm going to do is I'm going to fix the focus on my other camera here. If you'll just Bear with me a moment. Okay. So I'm calling up the dialog box for that camera through the video software that I'm using. So we're going to focus it up about like that, I think. That might be too close. A little too close. Because the radio's operating, I can't jam it in there. The camera I'm using has a metal ring right on the face of it that is conductive. So I believe. Okay, so now we're going to try to trace this wire very carefully. First of all, who is it? It's pretty sure to be that orange one. Hey, it just happened to the radio. I didn't touch anything. The voltage, the sound went down, the voltage went down. That's very unnerving. Seems to me it happened at the moment the furnace started in the house here. Yeah, the furnace did it. Okay, so we'll follow that orange wire very carefully into the dark. Into the dark. Let me bring over the lights. So, pin 7, 6, it's pin 5. Okay, so I think it's pin 5 now. You know, if it's not 7 and 6, it's kind of got to be 5. I mean, it can't range all over the place. Oh, 5. So 5 in the book, which I didn't leave open. 6A, Q. 6A, Q. Q, 6AQ, 5. Pin number 5, plate. Wait a minute. How do you check that? And it's a capacitor to the chassis from pin number 5. It's definitely the output tube. Definitely. Well, if it's not 5, it's 6. And if it's not 6, it's 4. 4 is a heater. There'd be something on the heater? Like that? Okay, so looking again at the schematic. Trying to find this capacitor. Back to this number 50. See, 50. It's very clearly number 50. 50.001. So, okay, so if that's not number 50, which one is? I don't know. I mean, that's a small capacitor, 0.001. Is there some chance that that's what that is? We're going to have to just remove it. Okay, so we're going to remove it. It's got to come out anyway. So I'm going to nip off the ground wire here. Grounded wire. Okay, and we're going to tug on it. Well, I certainly identified the right wire. Oh, okay, let's see if I can cut the other wire now without cutting too much other stuff. These are the speaker leads, by the way. I want to make sure I get the right thing. Where's that? Yeah. No question. This is it. Ugh. Made in Britain. Lots of patent numbers on it. 0.005. Oh my gosh. And it's got to be a 600 volt. 600 volt AC working voltage. 0.005. Isn't that a monster? Why, I just was sure this would be like a 0.1 or something like that. Let's give it a go. This one's roughed up. The wax coating is roughed up on it a little bit. But the other ones, even with the beautiful looking coats, not so good inside. Here's a quick COVID report from Ontario here. People are panicking in the medical system. People are in a panic now. Everything's full up. But at the same time, our rate of rise of new cases has stopped rising so rapidly in the last few days and appears to be leveling out. I mean, that's a good thing, but where it's leveling out is we can't sustain it for any length of time. Here we go. Open right up. 150 volts. Look at that. This is a good capacitor. Son of a gun. Let's try reading its value. Just give it a moment to bleed the charge off. Okay. 0.005 is going to show up on this scale. So I'm going to swing the arm around, and where the eye opens, that's our capacitance. It's right at the end of the range here. So well, kind of see a bit of a peaky thing happening. What does this say? That's 0.001. This is 0.005 up here. Now 0.005 shows up on another scale, but right at the end, right at this end, that 0.005 is right there. Ooh. You probably can't see what's happening, but the eye is flickering a bit there. Doesn't open at all. Well, 0.005 capacitors are not expensive. The 0.1s are a little bit expensive. You don't want to rush them into a radio unnecessarily, but a 0.005. Okay, so this big guy is going to be replaced by a relatively small capacitor here. My choice. One like that. Okay, let's stick this guy in the radio and see what it does. Alright, let's do another test on that same capacitor. Just use a completely different instrument and we'll see what it says. This guy doesn't exactly measure leakage, but it will show some other factors, including the capacitance. Let's see what happens. So this thinks this is a 6,000 picofarad, 7,000 picofarad. 7,000 picofarads, 0.007. That's really close. You know, 0.005. The other meter said 0.001. What is going on? We don't know. I don't know. Just you know the old thing. The man with two watches never knows what time it is. But there's a corollary to that, and that is the guy with 1 voltmeter is going to claim a certain voltage. Does he really know it? Or is his voltmeter a problem? Or his capacitance checker? Or what? Okay. I'm halfway through putting this new capacitor in, and what did I do with it? I got so excited messing around here. Here, it's back in the tray. Okay, he's going in. Like it or not. Okay, this is a pretty tight spot to work in, and I've gone ahead and made it a lot tighter by sticking the camera up in here just for fun. Now that's the wire I want to get. This one here. Pull the thing off. Okay, it's off and gone. Hey, what's going on? What happened? Sound came out of the speaker there. I am playing around with the output tube, and I guess some capacitors have a bit of charge left in them. Now I've got to get the lead wire up there. Just to remind you of the schmozzle I'm working in. Here's a quick look. Yeah, so I got to get way up in the back here. That's where I'm working. The speaker made a noise again. Oh, it slipped off. What's happening here, as soon as I get the tool onto it, I'm blocking the light. That's on the wrong. What happened here? Lost track of the other wire. Okay, that's not bad. Just like that. That's laughable. 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 I'm not sure. Well, I may get a little more here. That's gonna work. Oh my God, I just looked up at the camera. You got a great view of this. I've got a lousy view using my eyeballs. There we go, squeeze it down. So I look in the camera, I can't really tell what's going on there. That's because it's right out of view actually. Bend this back here. We're not getting anywhere there. It's in the laughable spot again. Try some finer tipped pliers here. Really about as good as it's going to get. You know, the other issue here is not just getting these two joined, but making sure they don't join with something else. Looks terrible in the camera, but that's about as good as it's going to get. Now I got to get a soldering iron up in there. How am I going to do that? I'm burning everything down. Okay, solder first. Get that in position. Okay, we're going to bring in the soldering iron here, which is bullseye. Lap up. I think it got tacked together just outside the view of the camera, but if it is, I can probably do a little more with the pliers here. Well, if it was tacked, it's not now. They're just not laying against each other quite right here. So I used to show all this kind of stuff on my videos, and then I stopped for a couple of reasons. One is it slows me down putting this stuff on video because I'm just hampering my own work. And the other one is, well, I don't know, are people really interested in watching this struggle? If you do this kind of work, you know the struggle. Hey, now that's a little better. I think I can lap solder that. Still doesn't look very good in the camera, but I'll go with what my eyes are telling me. I'd love to fill that whole thing there, but it's not gonna. Oh, looks like I did. Now, you really don't want to use solder as your conductor, but look at the situation here. Many circuits are fairly high impedance, so you know, a couple of ohms in your connection here won't matter. Okay, did we get this? We sure did. Is it shorting? Something down low there, just behind the red wire. That's the end of the lead I just soldered in there. It's from this angle. Ooh. From the angle on the camera, it looks like it's ready to contact. And the other terminal. Let's try and see. I don't know if I can get another angle on it. That's the wrong end. So actually, it's a fair ways away. Yeah. So I mean, that's not very good work, leaving those little tails hanging out, but who owns this radio again? Oh, it's me. It's me. So I think I can tolerate my tails. Okay, so we got another capacitor in here. I think we should repeat the test. Now, what was this one doing? This one was this one was in this curious position here. Let's see. It's a small capacitor. You know what it's? I think it's trying to knock out any RF. It's on the wrong side of the. They didn't put a dot here, but I'm sure that's where it's connected. I mean, I saw that's where it's connected. They failed to put a dot here. I'll have to send a note to the drafting department. Well, it's all involved in the audio stuff, so I can't imagine how that's going to affect the operation of the radio. So let's not play the radio at this point. Let's go after that other big one up there. That's the bypass here. You know, that's another one that just won't affect the operation of the radio. Well, there's one more biggie down here. The one that goes, yeah. That's the one that we should really take a run at. This big one back here. Now the difficulty with that, and next to it are 1, 2, 3 more. I should do them all maybe. But let's just get after the big one. This guy. Ground it to the chassis here. Yeah, radio's off. Whoa. And the other wire. Good luck spotting that. Oh my gosh, it's just... Oh. That doesn't look good. Trying to change that one. It's really hidden in there. Let's get the other camera going. It's really, really hidden in there. So one end's easy. The other end... comes up, orange wire. Oh, lucky break. The orange wire is perfectly visible up here. Now let's just be sure of that. So capacitors here, and I think it has to be this orange wire coming up here. Oh, lucky break. Now they have it positioned right down against the chassis. I would like to just shoot it across. Why didn't they shoot it across? Either to keep it, just to keep it, you know, it's just good to tuck it down there, or there's a reason why it's down close to the chassis. And that reason would be supposedly the radio works better when it's down there. Oh, such debates. And can we see the size of it? DC working. We cannot see the size of it. Well, it's a lucky break. Because for sure, if that capacitor had been... Just to get a better perspective on this. This orange wire right here is going to that capacitor. So let me nip it off. I'm going to leave a bit of wire there, as always. Okay, I hope that was the right one. I'm going to nip the other end of this, because I know for sure this is the right one. Come out, come out. Point 1. Very good. Okay, so I'm going to put a 0.1 back in there. Then we'll try the radio. Hey, let's not miss out on this fun here. Okay, put your bets. Put your bets down. What would you bet on this? From what I've seen so far, I would bet this guy is leaky. 15 quatlos on the leaky capacitor. 50-volt test. Right open. 150, not quite all the way open. 250, still opening a little bit. So again, the capacitor is not terrible. The position it's in has something to do with grids, I think, from looking at the I better be careful now. Give myself a shock. 0.1. 0.1. Okay, I'm going to install that guy. I won't make you watch this time. Yeah, I've decided, you know, I'm in here on a nice sunny day. I'm going to make you watch this happen here. Get him up. So I am following the original wiring of the radio. Down you go. capacitor here. Too much cover on it, I think. Okay, there we are. Kind of use the old wire to pin the new wire against the terminal. Sort of. Well, that's what I'm trying to do. There we go. Good enough. Yeah, if that other capacitor had been tied way around at the bottom of this switch, I'm not sure what I would have done. I would like to change them, but I wouldn't imagine if some of these things are assembled outside the radio and then they're put in the radio. And that could put components like there are resistors and stuff. You can't get at them here without taking the whole switch out. Which is a big gamble. Big. That's a big ugly gamble. Never done it. I think I'd be more inclined to leave the capacitor where it was. Okay, I got the other wire right off, didn't I? Okay, this is too long. This isn't soldered. This didn't solder here. Doesn't want to cooperate. There. That's better. Let's try again. It's still not soldered. Huge terminal down here. I don't know. Go. I don't know if my little soldering iron's going to do it. That's got to get it there. Take a little while for the heat to flow here. Which I can't melt the whole thing. Melted in that area there. Looks good. Okay.
no good. Then you have to do something different to solder down here. Well, that looks good. Get some more solder in there. Ah. Come on. Oh, I think that's got it for sure. Let's check the other end. That's gotta do it. It's definitely got it there. We're good. Bend this a little bit. Make sure there's no shorts there. Good. Time for another test. Okay, once again, everything is the same as it was, except for the change I made. Speaker still connected. Okay, here we go. Comes. Okay, back to the 5 scale to start with. So first time we were up here, 4.3. Now again, the radio tuning may have varied on this one. Why do I think that? Oh, I don't know. Okay. So I wait for that long duration upswing. I should before I do anything, because it's still moving up ever so little. Yeah, still moving up. Okay, I'm going to go ahead and tune just a wee bit here. Watch that meter. I don't hear the there it is. Okay, watch. So it's just about dead on. Oh, well, I jump up there. What goes on with this tuning? There we are now. You know, I think the radio is drifting. Maybe the last time I had it tuned, not dead on, and it drifted into tune. It's doing the same thing. It's going up. Okay, I'm going to leave it running here for a few minutes. So I've just been standing here studying the schematic a bit, and you can see what's happened. The meter's gone right over. I'll put it up on the next scale. The new number was 10.5. So we're at 6 right now, 10.5 up here. I bet you if I tune the radio, it'll go up. So this capacitor I just changed, is switched into the circuit, and it looks like not on all bands. And it appears to be attached. First, it's connecting the bottom of this coil to the B minus through that capacitor. Probably doing the same thing on this one. Oh my gosh, it goes into this tone control. But yeah, don't know. The wire goes another way. It's going up to the grid here, so it's grounding the bottom of the grid resistor here. Come over here, the same thing. There's a grid resistor, so it's supplying a AC ground or a signal ground on the bottom of the grid leak resistor on each of these. It's definitely affecting the grid. You affect the grid, you affect the strength. You affect the strength, you affect this. So it's easy to see that this would have some kind of a effect, hopefully a positive effect. Maybe that even threw the alignment out a little bit, so there's many factors here that are varying at the same time. I'm going to tune now and see if we can get this up to the 10, if it goes up at all. Down, down, so it's not going to go up. So we've ended up with a new number, but this number might be, as I said, indicating alignment would restore it to 10 and beyond, maybe. So now we're at 8.2. Just making a note. And that's going to be it for today. Because as I showed you, the sun is shining. And I'm going to head out there. So wow, I thought I'd get through all these capacitors no problem at all. But again, it's been another bit of a slow process. So thanks a lot for watching. And we'll just keep going on this radio. I got big plans for experimenting with this radio, by the way. See ya.